attending the conference. I'll present to you the BIM and BEM integration. So, as you all know, now we are witnessing a global crisis of energy and resources, and the AEC sector is one of the biggest consumers of water resources and energy, and it also produces a lot of waste. So there is a crucial need to implement more the sixth dimension of BIM, which is sustainability. And we have a big need also to implement more high-performance green buildings that can provide better economic environmental performance. And this type of buildings can help us economize natural resources, save more money, and provide a healthy and comfortable living space for the users. As a matter of fact, we can use BEM or energy modeling at any stage of the design, from pre-design until construction and operations. And it will help us design more efficient buildings, more streamlined construction, produce less waste, and reduce the commissioning time. BEM offers a lot of opportunities, and mainly for designers, it will help architects to reach their energetic goals, and not only to assess, but also to control the energetic performance of their designs. And it also creates new technical expertise and opportunities for professionals. As for building owners, the biggest advantage is to reduce the cost of construction operations and maintenance. So the previous literature have showed that in the past years, there is more interest in the technological aspect of BIM and BEM integration. And this is due to the fact that we have a need to solve the technical problems, and I will talk about that later. So the biggest issues or limitations that we found during the literature reviews can be grouped into two main categories. The first is technical limitations, which are mostly related to interoperability problems that can lead to more rework, waste of time and data. Also, the accuracy problems that can decrease the efficiency of the final model. The lack of standards that can define the energy-related properties, and technical problems that arise when the projects are bigger and more complex. As for process-related issues, the biggest limitation we have is the lack of an easy-to-use generic BIM-BEM process map that specifies all the required details and the suitable model integration and work and data flow within the design process. In addition, most BIM-based studies actually disregard BEM aspects, so we don't have a big reference when it comes to requirement and activities. And finally, the absence of a reliable model to follow in terms of content of a BIM-based model, and the clarity, because the clarity of information requirements and steps to follow are actually a big part that is needed and we are missing. So to process with the integration, we have three models to follow. The first one is the combined model, where the model is transferred directly from the BIM tool to the simulation tool using a plugin. Then we have the central model, where we use a data schema file such as IFC or GBXML to translate the model from BIM tool to the BEM tool. And finally, the distributed model, where middleware is used to enhance and modify the model, and using plugins from both the simulation tool and the BIM tool, we can transfer the model. In any case, we need to identify a comprehensive data workflow at the early design process and identify all the design aspects, such as activities and requirements, that will help us limit the rework and make the process more efficient. So in a very simple way, the BIM integration is like this. We have a set of inputs related to the project, such as the building geometry, the control scenarios, and all the activities, information requirements, LODs that are transferred to a calculation engine that all the energy simulations use, such as Scobie tool or Sapphire. They use a calculation engine to run the simulation, and then we can export our results that are either textual or graphical. And architects actually need, or whoever uses these energy simulation tools, they need an easy and seamless data transfer, a robust engine to run the simulation, a comprehensive resource analysis, a clear graphic inputs, and a real-world accuracy. So the questions, the most important questions are: what opportunities do BIM and BEM offer to designers, and what type of limitation they can face in the process? As designers, what would BIM offer to us when we start working on project? And would this integration contribute to the efficiency of the design workflow and the design itself? And how would it affect the design process in general? It has been said actually that 80% of how a building performs is actually decided within the first 20% of design. So this step is very important. That is why we need to evaluate all the challenges that could arise while performing an energy simulations, and also observe the potentials that BIM integration could offer to us. We actually do believe that the use of energy simulation tools with a straightforward workflow would actually help and assist designers to have efficient designs and efficient workflows. So I started with the literature review that helped us identify the main limitations and potentials, and using a case study that is a building, I ran the simulation, and I ran a series of simulations and comparisons in order to assess the efficiency of using a BIM workflow, and also the efficiency of the design itself. So I started with an office building that is located in Ljubljana in Slovenia, and it has 4 floors and around 5,000 square meters of area. And then the next step was to identify or design a process map that I will follow in this assessment. So the first process map is actually adapted specifically to early design stage, and it starts with the most important part is the pre-processing, where designers should identify and define the information requirements, the LOD, the project objectives, and all the sustainability aspirations. And these steps would help actually the designer to make decisions for the future. And as you see here, most of the work is done on the BIM offering tool. In my case, I used Revit. And then I adapted this integration map to the software I used, which is the Cove tool. It's an online platform that where the project is directly transferred through a plugin from Revit to the online platform. And here, as you may notice, instead of checking the model for errors, we are checking the model for element views, which are specific to the Cove tool. And more work is actually done on the simulation tool rather than the BIM tool. And most of the inputs that are related to the location, the thermal properties, the shadows, etc., are directly inserted in the code tool. And then I used some outputs that would help me assess how efficient is the design. And mostly they are spatial daylight autonomy, the annual sunlight exposure, lead score, and the energy use intensity. And the first simulation was regarding the optimization of the orientation. So I compared 3 rotation degrees of the buildings, and according to all the outputs or the parameters that I listed before, I could identify which one actually uses or help us consume less energy. And then I could go to the next step of design, which is identifying or defining, sorry, the facade. And here as well, there is I use the comparison tool to identify which facade system is actually more beneficial. But before that, I used a real-time simulation feature in the Cove tool to identify or compare directly in real time which facade system I'm going to use, the dimensions of the openings, the fins or overhangs, the number, etc. And then I could take it to the next step and compare 3 types of facade systems, and same as before, identify which one help reduce the energy and provide more comfortable indoor space. And finally, the last step was to identify the materials using the U value of each wall type. And then this value is actually inserted with the schedule of the use of the building, all in the online platform. And using also the comparison between the 4 types of walls, I could identify which one is actually, or which one gets me closer to my sustainability goals. And then finally, to make this design better, the tool offers an optimization feature using cost versus energy, and it provides an unlimited number of scenarios where we can improve actually the design, and then the designer can identify which, for example, I used here the cost premium, means which how much money I want to invest in order to improve the design, and then limit the amount of money I want to invest, and then the tool provides all these possible scenarios to help with this. So in conclusion, what we need is a clear and an elaborated process map that is adapted to the proper design phase. And in my case, we need focus more on the pre-processing. That is the decision-making point of each for the designer for each design step. As a matter of fact, using BIM at an early design stage would help the designers to unleash their creativity and to design, to assess more design options, and also run energy simulations without the need of specialized engineers, and also help reduce the amount of time for rework and the amount of data that is related to energy. And finally, using some tools such as the POF tool can help designers to explore more options and to make quick decisions using features like the real-time simulation or the optimization. So what do we need in the future? We need to develop a complete digital twin containing not only the architectural model, but also the energy performance data. And this serves as a reference for such kind of integration. We need to solve interoperability problems, which is one of the biggest limitations. We need to improve BIM-related standards. And finally, as a suggestion, maybe the software providers should investigate and propose an adapted process map to their or the features of their softwares. That's all. Thank you. If you have any questions.